Hei og velkommen til Hackon og Google Security Day med Florian Opitz. Dersom du har spørsmål, så kan du stille disse i chatten eller under Q&A, så vil du få svar. Vær så god, Florian.
Thank you, and good morning from my side. Unfortunately, I'm not speaking Norwegian, so we are going to have the session in English. I hope that's all right for you. Let me start out with sharing my screen right away. So, yeah, and again, welcome from my side to today's Google Cloud Security Day. Honestly, it's just half of a day. We initially planned to have that session actually on site in our office, but as you all know, the pandemic situation doesn't allow yet to do those things, so we are still kind of meeting only remotely. I still hope that you will pull out a lot of kind of new knowledge, new information out of it. Honestly, it's just a half day, so I will basically be only able to cover kind of a general overview, not everything, as Google Cloud has a wide range of offerings, wide range of products. It's not realistic to cover everything in approximately 3 hours, but I will try to do my best to give you a good picture as full as possible. So first of all, who am I? My name is Florian Opitz. I'm a customer engineer here at Google Cloud. I'm not based in Norway. I'm based in Munich, Germany. I've been working with Google for 1.5 years now, have been working in the IT space for many years before that. Actually, I strongly focused on the Microsoft side for many years, worked for Microsoft directly, worked in Microsoft Consulting, worked with cloud technologies, not only related to Microsoft, of course, Google and AWS. So I've got a pretty broad picture of the IT world. With me today is Ragnar Nikolaisen. He's our colleague who joined in January, new in our Oslo office. So even if he's basically only listening in today, he will probably be the kind of main contact for many of your inquiries in the future. So he's particularly focusing on the security topic. In comparison, I personally focus on security as well as Google Workspace. So these are my main areas of expertise. So what are we gonna cover today? You see, we have 5 pillars of the agenda today. So my first would be intro to Google Cloud security concepts overall. That's probably a good starting point to know what's always there, what you can always count on, what you don't need to think about a plan for if you're looking into security aspects. It's just there for you. So that's the first starting point. Then I will dive deeper into our Google Cloud platform, our platform where all the infrastructure as a service, platform as a services are hosted. As it's a very wide platform with many capabilities. Of course, governance, planning, doing the things right is very important. And I will give you some guidance on how to do it right, on how to get started right, and where to find more information on how to do this in a right manner. Then we will look into Google Workspace security. Google Workspace is tightly integrated with Google Cloud, but has a slightly different positioning in terms of what it covers, what it's made for, how it's built, and basically where you configure the settings alongside your requirements. So I will give you some guidance there so that you understand how it works, how you configure it, how you do it right, and of course also where you can find more information. Then I will give you a brief overview on our multi-cloud, hybrid cloud security offerings. There are a lot of offerings there as well. I will mainly focus on 3 topics, which I feel are very important, will be key features or key products in the future. A lot of things are happening in that space. And these things are really built with a multi-cloud mindset. That means it's not required to use Google Cloud for this. This can work either if you have systems on-premise, if you have systems in the Azure cloud, in the AWS cloud, or somewhere else. It really embraces the whole concept of multi-cloud, and I will tell you how it works and what kind of use cases these areas address. Last but not least, we will end with a Q&A session, so kind of meet the experts. We'll stay in and be open to your questions, concerns, whatever. I also like to encourage you to make use of the chat here in the platform. So if something is unclear, or if you have any questions, if something is not working out, like, okay, the video is not coming, or it's kind of frozen. If something like that happens, then please just drop a chat message, and I will try to address this right away. All right, so let's get started. As said, starting point is our cloud platform, or Google Cloud, or Google security concepts. As you may know, Google offers cloud services, but offers a lot of other services as well. Services that you're probably using pretty often, as many people do in the world: Google Maps, Google Search, YouTube, etc. Systems that run at a large scale, which serve billions of users. Basically, the technology that provides that scale and provides that security, in that sense, that we are not hit hard by denial of service attacks, account breaches, etc. Basically, the concepts that we embrace within these large-scale services, these are the concepts, these are the technologies that any Google Cloud customer can use for their own applications or use cases. So it's not that we build something for Google and sell something as an IT service or cloud service provider to our customers in a different way. It's the same technology that we use. And honestly, that basically proves it's really battle proven. It's working on a daily basis at a large scale. So that's kind of one of the core concepts. When we look at Google Cloud, the systems that you can use for your own use cases, the pillars are the Google Cloud Platform, Google Workspace, obviously the identity and access management piece, and capabilities for managing mobile devices in general. You see, there are a lot of icons which represent the Google world, like the Chrome browser icon, the Android icon, Gmail, etc. But that's not limited to the Google space. So we can work with other software vendors as well, operating system vendors. So you can easily replace the Android icon with the iOS icon, or with the Windows icon, or the Mac OS icon. It's not that we kind of just look at it from, that's Google and that's what we care about. We really look into what our customers have, and that's a broad scale and very with many differences in what the customers use. In any case, we built our solutions, the things that we provide, with a security and privacy first mindset. Sometimes people feel like, okay, privacy, why should Google care about privacy? Google is selling my data. And Google is just collecting my data for providing advertising. Honestly, that's I would say, a pretty clear misconception. We could basically shut down the whole business if we would not secure the data that we store, that we manage, if we would allow the data to flow out. Do we make revenues out of advertising in some areas of our business? Yes, we do. Is this relevant to Google Cloud customers? No, it isn't. So it's a clear statement. Advertising is a different business. It's a different branch that doesn't at all relate to Google Cloud. So there is no advertising. Any customer is owner of the data. So it's not something we just manage it as an IT service provider in a secure way. And we do this by the kind of long year experience that we have by providing those services at scale in other use cases. So as we can rely on this experience, and as we can rely on that large scale infrastructure, so basically that's something, even if Google Cloud is in some people's view kind of the challenger, the third in a row after Azure and AWS, it's still there. Google has such a large infrastructure, such a large network to benefit from. Actually, one of the largest network and most performant networks in the world, which connects our systems, which are spread all across the globe. A specialty for Google is also we have close collaboration with lots of ITs and internet service providers across the world, because basically it's a requirement for internet service providers to provide good access to Google service to their customers, because the customers are asking for it. The customers are using YouTube. Customers are using Google Search. The customers are using Google Maps, etc. So the access to it needs to be as performant, as good as possible. So a lot of partnerships are already in there. So you can typically benefit from those partnerships, these points of presence, these interconnects that we have at scale, even if you're not kind of using classical Google services, but you're using Google Cloud services. So that's a strong thing. Obviously, as we have this large network, it's a good thing that when customers enter our network, it stays within the network. It's always encrypted within the network. We can easily manage the typical risks that customers typically see if traffic flows through the regular internet, through the various hops. There might be a higher risk for a man-in-the-middle attack. If the connection flows through the Google network, we can take care that this is not happening, and we are guaranteeing that everything is always encrypted, which is a huge security benefit per se for our customers, no matter where they are in the world. We take also a lot of we have a lot of focus on on the data protection and data privacy aspects. That means if data is stored within Google services, this data shall be protected against flowing out of the customer's control. And the strong piece that we have basically enabled in all Google Cloud services, or at least in most of them, is data loss prevention. So we can help you identify sensitive data depending on pre-configured so-called detectors. Like, we can make it easier for you to identify what is personal identifiable data, what is social security number, what is credit card data. We help you to identify that data no matter where it is. If it's stored in files, if it's stored in databases, if it's stored on local storage, doesn't matter. We help you identify that, and we can help you take the right measures out of that detection. So you can say, okay, if that's sensitive, I don't want that data to flow out, to be shared to someone externally. I want to make sure that data is always encrypted in the right way with my personal key. I want to make sure that it cannot be shared with anyone. So basically, that's something that we bring no matter which service you're using. It's also a strong thing. And last but not least, and I also kind of mentioned it before, we always encrypt everything. So no matter if there is if it's the connection from the client or from the customer's network to the cloud or to our service, this is always encrypted, transport level encryption. When the data is stored within our data centers, it's always encrypted on the storage layer. So the storage layer itself takes care of the encryption. So every service that sits on top of it automatically benefits from the encryption. And we make it transparent what encryption mechanisms we use, what algorithms we use, what libraries we use for doing so. So that's a very, very, very clear thing. On top of that, we also support in-memory encryption. That means while the data is being processed, while the data is being loaded into the random access memory and processed by the CPU or GPU, it's kept encrypted and not decrypted, kind of processed and then re-encrypted again. It stays encrypted all the time. So that's something that we support, and that's something that any customer can rely on without any further ado, without any further products that need to be attached to the infrastructure. It's just there without any further ado. So this kind of idea of security being built in, not bolt on, is a very, very strong thing. And we also believe, and you will see that later in my presentation as well, that this belief, sometimes it's better to change the architecture of a certain application instead of just saying, okay, we are gonna run it in that way as we did before, and we just attach technology which protects that. Virus scanner, proxies, threat detection systems, whatever. It's really about, if you do the underlying infrastructure and architecture right, then you don't need to kind of bolt something on, which is maybe not fixing all the issues. And we are seeing that, unfortunately, quite a lot in the IT space, that kind of certain approaches are more likely to be hit by ransomware attacks, advanced persistent threats, etc., than others. So we really believe at some point it's not about just attaching something. It's about doing the things right initially. So the things that we do are valued by kind of typical players in the market that you may know. Gartner, for instance, Forrester Wave Studies. They see Google and Google Cloud Systems always in the leader area. So you see in the infrastructure as a service security area, we are kind of top notch, as seen by Gartner. We also are top notch, and I guess I had it here, by Forrester, related to securing unstructured data, which is kind of the reality in modern IT, that you have a lot of unstructured data and less structured data, more meaning less relational databases, more NoSQL databases and such. So we are a leader in that area as well. So to give you a better overview of how we do the things in reality, obviously we have a layered approach. So one supports the other. It's not just kind of we focus on one, it's the whole pillar, basically, of technologies which need to work together. So let's start at the bottom. Obviously, for any IT service, you basically need hardware. The hardware that we run is mainly Google custom-built hardware. It's not something off the shelf. Google is the largest hardware or server producer and not selling a single server. So we produce the hardware ourselves. We are making sure that the hardware just meets the specific requirements and does not do anything else than that. Because everything else, let's take a mainboard, for example. A mainboard with certain components. Every component is a potential threat surface. So if you just want to have a specific function with that, just have that component which does specifically that and nothing else. So you reduce the potential attack surface. That's what we do. So the core components like mainboards, network cards are always Google custom built. We are using, obviously, other hardware vendors as well, commodity hardware vendors. So obviously we don't have our own CPUs, for instance. We are using Intel CPUs or AMD CPUs. Typically, we are providing NVIDIA GPUs, but we also have our own TensorFlow processing unit as a kind of replacement for typical GPU use cases, mainly related to machine learning. So custom-built hardware, that's a specialty, and that's something only Google does in that way. When we deploy a service, it's all verified from the beginning to the end. We verify every single deployment so that it has passed all the kind of security checks. Is it coming from the right deployment source? Is it signed the right way? Is it targeting the right systems, etc.? So there is a very, very sophisticated process going on. And if anything happens there, if anything looks fishy, we immediately roll back. So it's all built in that way that we can immediately respond to aspects that something was wrong, there was a bug introduced, or in worst case, there might even be a security threat coming in by kind of third-party software that is involved in a sense. Libraries that are used, open source libraries. You may know there was a recent kind of real serious threat with a log4j problem, which basically was used by many software titles, and it also was part of some of our technology, but we can see that we can immediately have that rolled out. So service deployment and verification of the services is very important. Storage services, I mentioned that already. Those storage services are built at scale. The management layer is all Google custom made. We use kind of hard disks, SSDs provided by the typical vendors out there, but the management layer is all ours. And the management layer also takes care that everything is encrypted on the storage layer. So that's happening there. Identity piece, there is not a single access to services without authentication. So everything needs to be authenticated, either user to system authentication or system to system authentication, service accounts, etc. And everything is very limited. We embrace a strong zero trust approach there. So it's not kind of this domain approach. If you have the access, basically you have the access for the whole domain. It's really zero trust. You only have access for specific APIs, for specific services, and so it happens. It's a huge management effort, but we have built that to scale. So it's really working that way. And maybe I can find some time later to quickly jump into the demo environment, and you will also see how it works there. So everything that you need to access requires authentication in first place and enabling you for that piece in first place. So this might feel a bit awkward in the beginning, because you typically need to authenticate and authorize a lot of things going on, but actually that's a strong security aspect as well. And it keeps this least privilege approach active from the beginning. Yeah, obviously the internet communication is an important piece. We have denial of service protection built around our data centers, and that really scales. So we had really large attacks, and honestly, Google is a target for this malicious actors out there. They definitely like to hit us. Or would like to breach us. And so we learned a lot, and we are protecting our infrastructure quite well. Basically, you can see this every day. How often have you encountered that services like YouTube or Google search have been down? Not too often, I would say. So that's basically the whole idea. And obviously, it's not all about tech. It's about people as well. So we have people operating this, but we have hugely optimized everything to keep the human error out as far as possible. So there is not a single thing that people can simply access our infrastructure single-handedly. Everything involves authorization and approval, at least manager approval, and that is not done easily. Only a few people are allowed to access our data centers. There is a YouTube video actually which shows quite nicely how we protect our data centers. So kind of that's the overlay. There is a lot of things going on, not only on the Google Cloud side, obviously on the whole Google side. What I also wanted to mention is we build our own hardware, as previously mentioned, and we guarantee that this hardware is not tampered with. So we verify the integrity of the whole stack by introducing our own custom chip who verifies this kind of central root of trust. So you can always make sure, okay, that works in the right way. the hardware does not do something which it shouldn't. It's not been tampered with. Everything is cryptographically verified. So that's what we always have within our infrastructure. A purpose-built chip. Basically, this chip and the design and what it does has been open sourced by Google. So you can really look into what we are doing. Actually, that's something that we always embrace. We share a lot. A lot of the technologies that we introduced basically for doing our own stuff are open source now. A lot of the things that we manage, when we manage software, when we manage software deployments, basically what's happening within Google data centers is Kubernetes, is containerization. Kubernetes, something built by Google, which is open sourced, or which has been open sourced by Google. Google is still the strongest contributor of Kubernetes, but Kubernetes is kind of, I would say, it's the industry standard for container orchestration. That's how we run all our services. So it's really built to scale, and we share our knowledge and we share our experience. Yeah, a quick view on our network map, or worldwide network map. That map is constantly updating, and it doesn't show you all the aspects of the Google network because it's too overwhelming, honestly, because there are lots of connections going on there. There are lots of Google data centers, not Google Cloud data centers, spread across the world, which are also connected here. The thing that I want to mention is we are typically building data centers with resilience in mind. We are always introducing 3 zones in a data center. So that's something that you can always see when you're using GCP, for instance, and you're provisioning, let's say, a virtual machine. Then you can always select one of the zones, A, B, Z, typically, and obviously the region. So there is a high resilience by the way how we separate the things. It's always a 3-zone approach. And even if we start in first place with 2 zones, it's always something which is close, soon getting 3 zones. So that's kind of a core concept that we have, and that gives us reliability and resilience, which not all cloud providers can provide. Let me quickly walk you through how we encrypt. Typically, I mentioned some of those topics as well. So every connection from the client, from a customer's network to Google Cloud is encrypted. We enforce transport level encryption. Obviously, you can have connections here using dedicated interconnect. You can have VPN connections to Google Cloud. But in any way, we don't allow unencrypted connections to our services. That's kind of a core concept. When you connect to our cloud and store something within the cloud, every single file is chunked, so separated, split in 3 parts. In that example, in reality, it's more than 3, depending on the file size, depending on other circumstances, but it's much more. And every file gets encrypted with a so-called data encryption key. Every file every file part gets its own data encryption key. So in that example, we have at least 3 different keys for 3 different file chunks. This key, this data encryption key, is then encrypted with a so-called key encryption key. This key encryption key is managed centrally in our key management service. And so you have a kind of protection for your key. Your data is encrypted and the key is encrypted. That's always happening without any further ado. And all together, this is stored all together. So for even in the unlikely event that someone kind of gets hold of one of those chunks, it's never the full file. It's encrypted with a key, which is encrypted with another key. So very, very, very hard to breach. And the whole thing is kind of open sourced as well. The libraries that we use here are open sourced as well. I can simply tell you it's AES encryption, typically at least 256-bit. And we are evaluating if we are going beyond that, but at the moment 256-bit is a pretty strong protection, I would say, honestly. So that's always happening without any further ado. On top of that, you could have your own encryption. You can encrypt that data again, either application-wise, or you can encrypt with keys that you manage somewhere else with an external key manager. Something that can be hosted in your own data center or at the partner data center, wherever you want it. So it doesn't rule it out. That's always happening. On top of that, you can take more you can bring in more encryption if you want, if you need that. Google has a team, an internal team, which is called Project Zero. And this team does nothing else than looking for security threats in IT, not only related to Google service, but security threats in IT. This team discovered these issues, these hardware-based issues with the Spectre and Meltdown issues that particularly Intel has, but applied to the AMD side as well. This thing was discovered first with the Google team. It was patched before before Intel could do something about it. So our data centers were protected against this threat even before other data centers, customer data centers, other clouds could do this. And we managed to do this at scale without disruption. So we are always introducing a concept of live migration, and we are kind of updating, patching hardware, software without the customer realizing it. So that's always happening. Also a core concept of Google Cloud security. We do a lot, but I feel like many of you probably know this diagram or a kind of that diagram. There is always a kind of shared responsibility. And we not only call that shared responsibility, we go even further. We call it shared fate now, because it's really about fate, destiny. It's not kind of just blaming someone. In a sense, you did not do your job. In a sense, it's a common thing. We need to work together. We do a lot in, sorry, my bad, that was a click too much. We do a lot in protecting what we can protect depending on the use case you're using. So if you're using infrastructure as a service use case, so you're basically running a virtual machine, then we take care of everything related to hardware, the secure boot, the hardened kernel of the hypervisor. We take care of the storage and the encryption happening there. We can take care of the security of the network. We take care of logging everything, what's happening there. But on top of that, it's your choice. We support you in doing the right things, the right steps, by providing you products, the images, best practice guidance, recommendations, and so on. But still, it's customer choice. That's a different story if you go up the chain and if you go over to like SaaS-based services, Gmail, Drive, part of our Google Workspace offering. There, a lot of the parts are taken care of by Google, and we don't even give you the access to kind of controlling the underlying infrastructure because we do it for you. But there is always something that remains in your control. And that is basically what's happening to the data and who do you give access to that data. We don't give access to the data if you don't tell us to do so. But that's your choice. So content and access is ultimately always customer choice. And if you don't want to have that, it's kind of a managed service approach. So involving a partner who does the kind of final thing for you. But there is always a shared responsibility. So security is never just about kind of selecting the right cloud provider and just adding a product to it. That's simply not enough. It's always a shared responsibility, and it depends on the level of responsibility you want to have or want to take or must take for your use case. So I'm not walking you through everything, but you see, obviously, security has lots of layers, lots of aspects you need to look in, from the infrastructure to the network, to the data, to the application security, identity access management, endpoint security, monitoring, compliance and governance, etc. These are kind of just hints that we are providing solutions or approaches in every of those areas. But really, it's about the use case you are having at hand. Yeah, it's not about kind of just using the full stack because it's not needed. It definitely is only something that you need to select the right things for your specific use case, and knowing where you are, knowing what applies here, where your responsibility is the first step in taking the right control. Honestly, I've seen so many customers kind of just saying classic IT security requirements, no matter what use case they had. It's just about, okay, let's talk about the virus scanner and the firewall. Okay, yeah, that covers a few aspects, but certainly not the whole thing. So if you just look narrow-minded at those things, it just doesn't work. And it doesn't provide you the security you want to have. It doesn't provide you the control that you want to have. So really know where you are and what applies at which level is very, very important. It's not only that we provide a lot of solutions, there are a lot of partner solutions that we integrate with or that provide their solutions on top of our platform. You see, like for monitoring, Splunk can be easily integrated. Splunk can be run on Google Cloud Platform. We integrate with firewall providers like Palo Alto, obviously on the network security layer. We work together with F5, for instance, on the application security layer. So web application firewall, for instance. So if you have, or if you want to focus on these vendors because you're familiar with them, because you're already working with them, because you're using their technology in your own premises, hey, keep it on. Keep on doing the same on Google Cloud. We give you the choice. We bring a lot from the underlying platform, from the underlying services. But if you prefer to work with a partner, you're absolutely good to go for that route. All right. So that was kind of the general overview of what we do There is a lot more that we do, but kind of that's the core concepts that I wanted to mention. What I now will do, I will walk you through Google Cloud Platform, governance and best practices. As said before, we only have 3 hours. So a governance and best practice workshop defining the things right can take 1 to 3 days in reality, I would say. So I can only give you hints what is important and where you can find the information. I will quickly jump into my demo environment, because I feel sometimes showing a demo environment speaks more than 1,000 slides. So I like to quickly jump into that as well. As I know, these kind of video conferencing solutions, or kind of doing everything remotely, is sometimes a bit kind of boring, and people simply need to move a bit or get themselves another cup of coffee. I will introduce some breaks as well. And what I would now plan, I will briefly start with that chapter. Then we will have a 10-minute break for getting some coffee, tea, whatever, or stretch your legs. And then we'll meet again. But first, let me give you some general overview. First of all, Google Cloud Platform provides you with resources. The resources that you choose for your use cases, no matter if that's a virtual machine, if that's storage, if that's database, whatever, if that's AI. Hundreds or thousands of possible solutions and use cases are built in or are basically usable at your fingertips. The first starting point that you need to kind of spin up those resources for you is having so what we call project. If you're familiar with kind of other cloud vendors, for instance, if you're using Microsoft Azure, they call it subscriptions, but it follows kind of a similar concept. So you need to have at least one project to provision resources. Projects tend to grow, not only because they are called projects, and you typically, as an organization, have multiple projects. It's also because it simply gives you more control, gives you more ability to structure your things. So having multiple projects is a reality. But then sometimes it makes it complex. If you start over from scratch, every project starts with the default settings, and you're kind of introducing the permissions again, the policies again, the templates again, whatever. It gets pretty, inefficient, I would say. So you can bring those projects into what we call folders. So you can structure your projects alongside organizational requirements, kind of hierarchies, depending relationships to certain products, or testing versus production versus integration, something like that. So you can structure it this way by using those folders. These are a can have, no must have. And on top of everything sits the so-called company or organization node, and that's where you manage all the accounts that you have. Basically, accounts are where the initial authorization sits. So is someone an admin for Google Cloud? Can someone provision virtual machines, or can this person only spin up and can the person only start and stop virtual machines but not create new ones? These are different authorizations, different roles that you can apply, and typically this happens here but can happen at a lower end as well. The only thing is you need to have the accounts, and the accounts sit in your organization. You can have your accounts federated with other identity sources, like you can synchronize them, like with the Active Directory or LDAP. You don't need to start from scratch, and that's definitely not something that we recommend. We recommend to leverage what you already have. Yeah, so kind of that's the general structure. And let me quickly step into my demo environment to just show you this, how it looks in reality. So this is typically what you're seeing when you're in the Google Cloud Platform. You have the console, the graphical user interface. It's not needed to use our graphical user interface. You can have code-based interactions with Google Cloud, and you can basically run scripts or use independent third-party or your own software to interact, because everything that we do here is basically calling APIs. Everything is an API. And these APIs can be called through the graphical user interface or independently from another source. So what you can see here, I've my organization, which is called fopitsaltostrat.com, and I can create new projects in here. Let me quickly do that. I'm giving this a name: security demo temp. And I say, okay, where will it be built to? So all the resources need to be built, of course. And where does it sit? It sits within my organization. And where will it be located? And there are the folders. So I can say, okay, I have a demo folder, which is basically my create, throw away folder. But where I'm pretty open, where I can do everything, where there are no organizational policies. Whereas when I put it in production, organizational policies will apply that will simply prevent me from doing certain things which are unsecure or insecure, like providing unauthorized access to certain to storage, which prevent me from providing external IP addresses to virtual machines, because I want to route everything through a central gateway. But in general, I just select this and go ahead. So I've got my project, and the project is then inheriting all which comes from the top, basically. All right. With that said, let's quickly have a short break. I would say let's return at 10. Yeah, let's make it this way. Let's have a short break until 10:05. So a bit more than 10 minutes. Get yourself a cup of coffee, and then we'll go on, continue with the GCP security configuration overview. All right then. So a few more seconds and then we'll get started again. All right, at least my watch says it's 10:05. So let's continue. Let's step back here to the console. What you say, what you've seen, I created a new project within my cloud console, and this project is now open to receive resources. And what I could do now is simply select the type of resource that I want to have, either by using this or just saying, okay, I want to do something like compute engine. Compute engine is our term for everything that does computing, which is typically also related to virtual machines. So I select this, and my first thing just needs to load. The first thing is authorization. I need to enable access to the API. I'm not allowed to do anything at the moment, but I can now enable the API to have access to that specific feature. So it's not open. Not everything is open. I'm just selectively add the features that I want to use. So everything else is disabled. So I don't need to take care of it. I don't need to manage it. And I don't need to worry of any potential security concerns that might cause. Like, okay, if I don't manage something, someone could access it. If I don't do it right, whatever. So enabling just the things that you want to have, that's the first step to do. Let me quickly, while it enables, let me quickly step into my other demo project because I've enabled it there already. Oh, sorry, that was the wrong click. And go to Compute Engine. So here we go. When it's enabled, it looks like this. And what I could do now is, okay, I want to create something. And as you may know, when you create a virtual machine, when you create a service, a lot of potential choices need to be made. In our case, it's okay. First choice is the name. A naming scheme would be a good idea for a best practice, honestly, to identify maybe the purpose of this service. Like, okay, that's maybe my domain controller. 01. Something like that. I can select where it's going to be hosted. And I say, okay, I'm not using this, I'm using Finland. Finland is one of our CO2 efficient data center with basically running on renewable energy most of the time. So then I select which type of platform I want to have. I see what my choices will result in. So that will cost me $28 if it runs for a full month. I can say, okay, I want to have confidential compute. So basically, that is the encryption in memory. I'm not doing this right now. I can define which service account is used there. I can define which access scopes this machine has. So to which services may the machine connect. So another authorization on a machine base or on a service base. I can enable basic firewall rules, and a lot more is available as well. I can define the networking and so on and so on. And then I can say, okay, now go ahead and create that thing. And I've not even chosen an operating system at the moment. The default choice, that's a Linux operating system, but I could have chosen Windows as well, Windows Server. It doesn't matter. Now it's working. But you see, there are a lot of choices and a lot of potential human errors if you do it this way. If there are only a few machines and services to provision, that might be okay. If it's just for testing, development purpose, that might be okay. But if you do this at a larger scale and you want to rely on, hey, all these settings are made in the right way, then you can define policies to minimize the potential options. Like you have seen, I saw all the regions in the world. I could give a policy only Finland is allowed, for instance. But it may still be too limited in a sense and not reliable enough, because if you leave choice, there might be choice taken in a different way. Maybe you want to guarantee that everything happens like from a blueprint. And that's what we really encourage is doing this basically in a infrastructure as code manner. So the thing that I did here with provisioning that machine can also be done by calling the API with the necessary inputs. Like somewhere here would be my choice for Finland. You see a lot of choices, which we're just kind of coming out from the choice I made in the graphical user interface. Everything here can be automated, can be provisioned by so-called infrastructure as code. And that brings me basically to my first recommendation for today. Think about this. If you provision GCP resources at scale, do this in an automated way. As said before, we are doing it internally, Google internally, this way. We are provisioning nothing manually. Everything is automated. And everything follows clear processes. And if something fails, if something is not right, it can also be retracted automatically. We provide the means to do so. And we provide that with our kind of own language, own approach, our so-called configuration manager. But we also support other players in the market which are pretty famous and I feel like are used widely across the industry, like Terraform. Terraform can be is fully supporting Google Cloud. Is even if you use Terraform, it's fully supported by our support. So it's not something that you do something independently. It's really we are all in on that side. We have our own means, but we fully support Terraform as well. And Terraform is basically a capability which can open up multi-cloud as well for you, because you simply define Terraform scripts and the endpoints are on the Google Cloud side, the Azure side, wherever. So it can be a bridging technology. Others are playing a role as well, are supported, Ansible, Chef, Puppet, a lot of players there. I personally feel that Terraform is so popular that I definitely wanted to mention it here. But bottom line, if you can automate your infrastructure provisioning, do it. That's as simple as that. Yeah, it really gives you control and validation, rollback mechanisms, and eliminates human error. And that's a very important part. Still, you need to plan. A Terraform instruction basically is based on what you want to have. So you need to know what you need, and you need to kind of take out the aspects that are important for you to make a choice. We give you recommendations on how to do it. There is a web page, basically. Let me open this up. Got it here. Where we walk you through all the typical aspects that are relevant, important for an enterprise-ish organizational setup for GCP, like define your resource hierarchy, create the organization nodes at the top level, specify your project structure, automate the project creation, and so on. And it walks you through all the aspects. So basically, that's what I wanted to emphasize today. I can just give you a glimpse of that in today's session. I cannot walk you through everything because it basically takes too much time that we don't have today. But this is all in there. Some of the recommendations that we make, like we definitely have a least privilege recommendation for your account. So the account that I'm using, for instance, right now in my demo environment, that's a full-blown admin. Can do everything, can delete everything, can modify all the policies. Basically, worst case from a least privilege perspective. So definitely something you might want to have. You need to have for the initial setup, but then stop using it. Strip it down. Use only the accounts or permissions that are really important. Exactly. That's the point for the moment. Let's now step into the sorry, one thing I forgot. That's what I wanted to show you. We give recommendations all the time, dynamic recommendations. If you click on this recommendations thing here, it will show you analysis based on your configuration. And in my case, it just says, oh my God, you are giving excessive permissions to some account here to those resources, etc. There is a lot of access to it, a lot of permission weakness, I would say. So that's definitely something you should fix. We also analyze, are you having kind of certain resources which are provisioned, causing costs, but are not used, maybe deprovision projects sitting there, maybe spin up for a test, then forgotten and still causing costs. So we recommend configuration optimizations in here. So the best practice list, knowing the stuff from the web page basically is good, but it's incorporated here as well, and it's dynamically analyzed on what you provision within the Google Cloud Platform. So, but let's look at how you typically start from a step-by-step approach. Infrastructure as code, as said, should be one of your main targets to achieve. Definitely, no doubt there. But you still need to plan. You still need to define structure. And what I'm going to tell you now is how you define that structure to make it secure. So first of all, in the beginning, we are plain. We are having access to Google Cloud Platform in a sense. We have created a billing account to be able to spin up projects, but nothing else. There are no resources, there are no projects yet. But of course, we are having something somewhere else. We are not starting from scratch. We are typically having our on-premise directory service, LDAP system, Active Directory, whatever, where my users are. I have local computing power. I have local storage. I have local applications. So basically, that just represents what I'm already having. Maybe that's not even on-prem. Maybe that's another cloud. It doesn't change the way how to spin it up on our side. So first step is making the move to cloud identity. Basically, that's defining this organization node, because even if you got a first account in Google Cloud, this all able to do admin account, it's not integrated with your existing identity. So cloud identity, that's our main function where you manage your accounts, and which can be synchronized with your existing directory, and we can embrace federated authentication, SAML-based authentication against those sources. Like, for instance, if you're using Windows Server and you're having ADFS, Active Directory Federation services, that's something that we can attach to. Or if you're using Okta, Ping Federate, if you're using Azure AD, it doesn't matter. There is an identity source, and this identity source provides SAML-based authentication, and we can authenticate against it. If you want to do that, it's not absolutely required. We, of course, can authenticate the users directly, but I feel that's an important move for many, many organizations. Second, when you have your users, you give them control. You give them at least some level of control. And that means you define within our identity and access management, IAM, you define, okay, that's an owner. This owner can create projects. This is an organization policy admin. As said, this guy or this person defines organizational policies like restriction of IP addresses, restriction of locations, restriction of encryption, and blah, 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 blah. So you can define those roles. That's something you better plan ahead, because you can obviously add it later and you can change it anytime. But kind of cleaning up the mess is harder to do it right initially. So it's certainly a good thing to get that done in a way that works for you early. As said, organization policies, you probably want to define those early. If you want to have certain restrictions, don't over-engineer. Don't give policies when you don't need them. That's a big mistake that some organizations do. Everything that can be managed will be managed. That is bad choice. Only manage what you need to manage. Only create boundaries where you need to have boundaries. That's my take on this. Organization policies give you the way to do it, because they apply then to everything that is created later. Next step would be you create a project. You saw that I created a project previously, and I called this security demo temp. And I already had this security demo project in there, both in my demo folder. These projects are run independently. Every project has its own network, has its own IP address range, is like a separated bucket, doesn't know the other, which can be a good thing, especially if you want to separate integration from production, probably a good thing. But it's not a good thing if you want to split projects and they should share something like common network information, having the same IP address range, having the same rules applied to firewalls, etc. So what we can do is have a so-called shared VPC. A virtual private cloud as our kind of network is called. And you define the rules centrally and just attach the project to this shared VPC project. So you only do the configuration once, and that's basically the project for the classical network administrator who did the firewall administration before, can do the firewall administration right here, because it's like the external boundary for all your projects. And it definitely eases the administration if you have it done only once and not multiple times by project. Then you create your kind of projects or networks depending on your high availability or resilience, disaster recovery requirements. I mentioned before, we have different regions in the world. There's our data center locations, basically. And within every region, we have multiple zones. And those zones share the same subnet. So you can have one server sitting in one zone, the other server sitting in the other zone, but they are kind of in the same subnet. So you don't need to think of regions as separate zones as separated networks. They share the same. So depending on your requirements, like with high availability, for instance, we could have the network setup in Finland and one in Amsterdam, for instance, because we want to have services sitting on both sides so that one can take over for the other if one should fail for whatever reason, or it's not accessible. Next piece would be connect to your existing infrastructure. You can always connect to the Google infrastructure by using your regular internet connection and using kind of the transport level encryption that we provide for you. That's something that is always there. But think of, you spin up a virtual machine in here, and you want to access this virtual machine through SSH or RDP. Both protocols tend to be, SSH less than RDP, tend to be not ideal when using it through a public internet connection. And if you run that service and if you provide the RDP access directly, it's not even transport level encrypted bus, because you decide to open up that connection to your application, to your server directly. So it's might not be the best thing. So what makes it easily manageable without kind of adding components like gateways which encrypt the traffic on top for you? We have certain things, but I feel like for many organizations, this direct connection between the cloud networking side and the on-premise networking side is an important step. And this can be done through a dedicated interconnect provided by one of our partners. You can spin up Cloud VPN and connect the networks depending on the use case you're having, on the reliability requirements you're having. But we have the options. So it's definitely a good thing to build that connection if you're having use cases which can definitely make use of that. If you're just kind of hosting web applications, what good is a VPN connection? Typically not so much. There are different aspects which are way more important. But still, if you want to combine your networks, you're absolutely free to go. And I feel like it's something that is very common. So, as we have now opened up the connection directly from our on-premise network, we are looking into connections coming from the networks that we don't know, basically the public internet. What we typically don't want is to kind of just set the resources free and just make them accessible all across the internet. Obviously, no. You probably want to have certain aspects set here that protect your applications depending on which layer they are. So you might want to have firewall. You might want to have something like Cloud Armor, which is also a web application firewall and denial of service protection. You might want to have a global load balancer, which load balances between the different regions for your applications. So that's something depending on the use case, but clearly marked towards that's the connection coming in from the public internet. The public internet can also be someone who's not in your environment, but your employee. Don't forget that, obviously. So if someone uses these little devices, smartphones, they are typically coming in from the internet and not from your managed network, obviously. So this entry point is important to them. You want to monitor the whole thing. We give you lots of logs already. So everything that you do within the Google Cloud Platform is logged automatically. We have an audit log and gives you an audit trail where you can specifically say, okay, that project was created. There was this virtual machine created by whom, when, and this configuration was done, etc. All this is audit logged. But that's not an application log. That's not giving you insight into what's happening within your application. So you wanna look into that, and we can take all the logs from all the sources, either within the cloud platform, or if there is a connection, from other sources. So you can put all those into our central logging system, which we call Stackdriver. Some logs are obviously already there, provisioned for you for the underlying network pieces. So there are firewall logs, VPC flow logs, etc. But for the application, it definitely depends on which type of application or which type of use case you're having. But you probably want to make sure that you see everything at the right level. And the log sync basically gives you the collection mechanism. It tightly integrates with a lot of services that we already have, and you just need to flip the switch. And for something that you create on your own, there are clearly defined APIs on how to interact. And this kind of brings me to this overlay management controls. Obviously, logs are important, but just looking at logs might not be giving you the right level of insight that you want to have and the right level of activity you want to have. So we have monitoring solutions in there, which basically give you typical aspects like how much CPU is used, how much RAM is used, has there been a lot of traffic to the machine, etc. You can alert yourself based on attributes. We have a security and command center which analyzes the logs even further or analyzes the resources even further, takes additional threat protection mechanisms, like, for instance, recently introduced, I guess, like it was last week or something. We introduced a new feature within that security and command center, which identifies virtual machines or resources within your Google Cloud Platform environment, which look suspicious in terms of crypto mining or crypto mining typically. You may know it's not so uncommon that kind of malicious actors try to take over resources, take over machines, virtual machine servers, whatever, to reuse their computing capabilities to crypto mine for them. And this is unfortunately a pattern which happens which happens pretty frequently, not specifically on Google Cloud Platform, absolutely not, in general in IT. And we provide now means to identify such behaviors, not only based on kind of, okay, there is a high CPU load, which probably will be, or a high GPU load on a machine, but more aspects that can really help you identify such malicious actors. We also provide a large-scale data warehouse within Google Cloud Platform. And the more you get familiar with Google Cloud, you will see the more often you will encounter BigQuery. BigQuery is a core technology for, as the name suggests, query of large data. Big data in BigQuery. And as you can probably imagine, if you collect a lot of logs, if you collect a lot of signals throughout your environment, there is a lot of data. And if you want to query that efficiently, BigQuery can be the tool of choice. So we are not just kind of reinventing technology just for kind of, okay, that's our data warehouse for security, and that's our data warehouse for all the other use cases. No, it's the same technology, and it works well on both sides, and it works well at scale. And this is one of the technologies, by the way, which support a lot of Google services. So even if you have not used BigQuery, knowing that you use it, you will probably have used this indirectly, because it supports a lot. It sits behind YouTube, it sits behind Google Maps, etc. So, last but not least, we have created all the surroundings. Basically, we have created the identity, the networking piece, the monitoring piece, and now we are getting started in actually provisioning our workloads. Now we create the service project, or the use case specific project, depending on how you structure it, which then sits alongside our requirements. This service project will host resources in 2 regions to respect the requirement of high availability. Obviously, it could sit in only one region as well, but for that specific use case, it's built that way. So kind of groundwork first, then with the at the actual workload. Also important is we have VPC service control, so we can make sure that kind of certain APIs are called only by specific resources that you grant access to. You basically have seen something like that in a previous example when I created the virtual machines. There was a setting where I basically allowed, on a simple scale, access to Google services or no access to APIs, and you can specifically tailor which machine or which service account can contact which API. That really done correctly really embraces the concept of zero trust, by the way. And you can specifically check each request that is happening to make sure that only authorized and valid requests are actually conducted. One more thing. It might be something that when you interconnect the networks, you may have different IP address ranges, and you want to have some kind of network address translation between them. You might want to publish your resources through DNS, and you might want to make sure that only users from a specific device, from a specific or with specific kind of circumstances are allowed to access your resources. So that's what we call context-aware access, whereas lots of the other configurations are really about kind of enabling, doing it right from the permission perspective, doing it right from the API perspective. The context-aware access is something very dynamic. It reacts to what changes with the user. If Mr. Opitz comes from a Google managed device, which I'm using for presenting right now, then I'm all good to access all the APIs. If I'm coming from my private smartphone, maybe kind of slightly integrated, slightly managed, then I may use only a subset of the APIs. If I'm using an unmanaged device, or if I'm coming from an unknown IP address, or if I'm signing in one moment from Germany and next moment from China, then this context-aware access can completely block access, even if the credentials are correct. So that's an additional layer of control, defining access to the services, no matter which services, based on the context of the user. And in modern world, where kind of this network perimeter thinking is not kind of the core idea anymore, because not every user that is typically using your services will sit in your network. It's more likely that the user is coming from somewhere. But you might want to make sure that you know the device. You might want to make sure that the device satisfies certain criteria, that the user signs in from the right locations, whatever. So that's a very, very strong thing as well. So kind of that's how you get started. That's how you do this step by step. Obviously, not every aspect here is needed. Obviously not. You can have simple use cases in Google Cloud which don't even need cloud identity, where you don't care about organization policies. Can be done. No matter, definitely no argument here. But if you do it at scale, you might want to think about those things early, how you structure the components, because really, as said, that is more security built in. It doesn't help if you just throw the next security, we do everything right technology at it and just hope for the best. The underlying infrastructure or the underlying service architecture is an important, and I personally would say the most important player in security aspects. All right. Just one more note to so that you can get a grip on it. I mentioned these organizational policies. These organizational policies, as the name suggests, come from the organization and are inherited down to the level of the resources. At each of those levels, you can interfere with it. I previously mentioned I have my organization, fopitz.altostrat.com. And I've got a folder called demo, and I've got a folder called production. And actually, I changed the organizational policies on this level. So my organization is pretty restrictive from the organizational policies, doesn't allow me a lot. Basically, only internal, no external, no access from external IP addresses. Very strong focus on every encryption, etc. Whereas my demo folder just gives me free fall, more or less, because I know I'm throwing away that stuff. Just saying, at either level, you can jump in and modify. Last but not least, the question of how many projects are typically good. From a technical perspective, you can have just one. And you have certain kind of limitations, so-called quota per project, where you can say, okay, so many virtual machines, so many IP addresses. There are limits, but these limits are typically pretty high, and you can request a quota increase if you need more. But it's probably not a good thing to just walk that path, have just few projects. Obviously, project complexity remains low. If you just have one, you just need to manage one. It's as simple as that. But here, with the identity and access control, it becomes complex, because you cannot simply separate, okay, that's project A, and here's project manager A, and project manager is owner, and the rest I don't care. And there is project B with project manager B, and you have complete separation. Here, you need to combine the two and make sure that project manager A doesn't control the resources of project manager B. More complex. Can be done, no doubt there, but more complex. The cross-project network traffic, obviously, if you just have a few or none, then you don't have much. So you don't need to take care of those network configurations, because you just have typically one network. Least privilege becomes way more difficult to have this. So simple and marked in green here, having many projects is typically a better approach. As said, there is always a balance, and there is no need to over-engineer stuff, because over-engineering and over-adding complexity or choice may lead to other problems. But in general, and in my personal experience, projects tend to grow, use cases tend to grow, and tend to shift. So don't stick to few, use many if possible. All right, that was kind of the general overview of best practices for the GCP side. It can be just an overview. There is a lot more to it. As said, there are resources that can be leveraged to take a deeper look into that, and to do more thorough planning. But more thorough planning takes a lot more time. As said, typical workshops with complex enterprise organizations are typically done in days and not just one or a few hours. Let's step over to the less infrastructure, more SaaS-based piece, and that is Google Workspace. For those of you who don't know Google Workspace, who don't use Google Workspace, basically what you're seeing right now is Google Workspace. This thing here. This here is Google Slides, and that's part of Google Workspace. And there are a lot more components within Google Workspace. There is our famous email service, Gmail. There is Google Calendar. There is Google Chat. There is Google Meet. Google Docs, Sheets, Slides, as said, slides you're seeing right now, forms, etc. Things for collaboration, things for storing your content and files, and things for the administration. Google Workspace and some of the components are basically free to use for everyone. If you create yourself a Google account, you typically get a Gmail address with it, unless you decide to use your existing email address. But if you don't, you just get a new account at gmail.com, and you can make use of these services. In fact, Gmail is the largest mail service in the world, almost 3 billion users worldwide. And it's the same Gmail that powers Google Workspace. But Google Workspace, the brand, really reflects the organizational use of the systems, which in comparison to the private side of the usage, offer a lot in that area, in the administration capabilities, mobile device management capabilities, security aspects, and things like compliance, archiving, etc. So there is a lot more to it, but the underlying technology is more or less the same. That's a good thing. A lot of people are already using Google Workspace and are quite familiar with it. Google Workspace, or kind of as it was previously called, G Suite, and before that it was called Google Apps for Business, is built as a cloud-native, browser-based system. Full stop. So this little fellow here, Google Chrome, or basically any modern browser, Firefox, Safari, Microsoft Edge, doesn't matter, we support them all. It's only about using the system through the browser. As you may have seen, the system that I'm using for presenting is actually a Chromebook, which is kind of the implementation of the whole idea. For modern systems, you typically only use a browser because they are web-based. It's not about installing client applications, it's just about using the browser. This gives you this gives you kind of a single place that needs to be controlled. And this single place is basically available on all platforms: smartphones, tablets, PCs, no matter where. Basically all modern work systems, I would call them, give you a browser. That's the only thing. And the browser is the only thing that needs to be taken care of in terms of patching, etc. And modern browsers support a lot of security mechanisms, like sandboxing, like restricting access to the underlying operating systems. And these browsers are regularly patched. And these browsers are typically used at a large scale. And so the likeliness for security threats being undetected in those browsers is pretty low. So if you think that through, Google Workspace, by its architecture, gives a security benefit per se, because it doesn't require you to install local applications, which need to be updated as well. And these local applications, as we unfortunately can see out in the wild, are often target for attacks like ransomware attacks. As you may have realized, a lot of the successful ransomware attacks basically attacked unpatched Microsoft Offices or misconfigured Microsoft Offices, full client applications with many capabilities, but many with a close connection to the underlying operating system, excessive permissions. And basically, these can be hit easier than Google Workspace or this browser-based architecture can. Honestly, we have seen 0 successful ransomware attacks against customers using Chromebooks and using Google Workspace, because those systems simply don't allow these modern threats to happen. That's one thing, and that's also something about our strong belief in security built in, not bolt on. Because if the underlying architecture is more secure by default, it cannot be hit easily. So what's your area of control there? So we have this architecture, and Google Workspace is a SaaS-based application. So as you can remember in the previous slide with the columns, Google Workspace was sitting on the right-hand side. So a lot of the things are taken care of by Google for you. You still control access to it. That's your choice. And you define the content that you store within it, and you define on how to manage that content. A central player in that space is our Google Cloud identity. Because basically by that, you control who can authenticate against it and who is authorized against Google Workspace, who is able to use the services in there to a certain extent. You can always, you can even have steps in there, like with context-aware access previously mentioned. So you can define, if you're coming from an unmanaged device, you have these capabilities. If you're coming from a managed device, you have these capabilities. So that's something which comes in here as well. So really embrace that idea of having identity as a central control point. That's the thing that you need to take care of. That's the thing that you need to do right. That's the thing that you need to configure according to your security needs. I often have kind of discussions with customers, and I'm again mentioning these firewall proxy-based protections, which simply miss the point here. Google Workspace, cloud native, the people access it through the internet connection, basically. You define who can access it, but you don't define it by restricting IP addresses, by restricting URLs, by filtering URLs, by SSL offload the traffic. That does not really help. Basically, the only thing is that is done by that way is, okay, you're basically stating you are not trusting the service, because that's the only thing you are achieving. You are checking against Google, not against a malicious actor. You're just checking against Google Workspace. So it really misses the point about of security. So cloud identity, that's the strong piece. And cloud identity is not only about users, it's about devices as well. It brings a mobile device management solution. It can manage Windows. It can manage Mac OS. It can obviously manage Chrome and Chrome OS. So there's a lot of things that you can do just by using that. And Google Workspace is just kind of a using part of it. It's not rebuilding it. And Google Cloud Identity is the same that you're using with the Google Cloud Platform. And you can use it for Android for work, for Chrome for work, and for other apps, third-party apps as well. So that's a strong thing. Focus on the identity piece. And obviously, you don't want to start from scratch here. You probably want to introduce this kind of synchronization here. In that case, LDAP, Active Directory, but there can be other systems as well. You can replace it by Azure Active Directory, by Okta, by Ping Federate, whatever you're using. We can synchronize and we can use those users within Google Cloud Identity. We don't even need to have the password of the users, so you don't need to synchronize those if you enable a federation to that sources. And so you can really take it the way you like it, but that's the core aspect. And as previously mentioned, this is important. Context-aware access. So you can define, hey, who has access, under which circumstances, for which applications. And with that being said, let me quickly step into the demo environment. I'm now logging in as another demo account for my demo environment. Stepping into the admin console. So that's how Google Cloud Identity or Google Workspace admin looks like. That's where I manage my users. That's where I manage my devices. And that's where I can integrate a directory sync. That's a new function that came in here, but there is a previous one that's still supported. It's just we are adding more capabilities for different architectures. So that's why it's called beta here. And there you have your users. I've got them synchronized here with a local domain controller, and there are users structured in organizational units, like you may know it from an Active Directory. And every user, let's just pick one. Every user has privileges, has access to apps, but doesn't have access to apps. Here you see 74 of 76 apps in here are available to this user. You see the managed devices of the user. You see the licenses associated with the user. You can flip the switch and simply modify things in here. Like you can say, all right, let's look into Google Drive, for instance. Google Drive, our platform where users store files, where they share files from. Basically, it's the core storage space for all of Google Workspace. More or less everything except Gmail stores the content in there. And you can define, all right, we can define the sharing settings. May it be shared externally? Does this user have the ability to share it? You can flip the switch. Like, just step back. You can flip the switch by user base, on a group base, on an organizational unit base. You can simply define it this way. So no matter where the user comes from, the authentication to Google Cloud Identity as soon as the authentication happens, Google Cloud Identity knows, all right, that user is eligible to use those APIs, basically those services. And you can restrict that completely, and you can restrict that by using this context-aware access. I haven't configured it here in my pretty fresh demo environment, and I could just say, all right, I'm creating a new one, and I want to have attributes that need to be met by the user to access certain things. And I can say, all right, I want to make sure that the device that the user is using encryption. So it's encrypted, and I want to make sure that only users in where is it? So many countries. Norway. I don't even see it. Here it is. I'm too blind. That only users in Norway are allowed to access it. This information is based on what Google knows about the internet. Google knows a lot about the internet, but as you may know, these geographic things based on IP addresses are not fully reliable because they can easily be tampered with if you're just using a different VPN connection, for instance, a Tor network. Then we don't see what the region is in reality. So it's not the strongest part, but it may be a part. And I can simply say, all right, save this. and I can now say, all right, I'm assigning this access level to the different applications, and I'm saying, okay, the users are only allowed for Gmail if they meet those requirements. So device needs to be encrypted, and they need to come from Norway. That's a take on that. And as you can see, as you could see previously, there are more aspects. Access level: is it an admin? Is it a regular user? Is it a specific IP address? More information based on the devices can be leveraged. So that's what context-aware access is about. That's a strong part. But that's kind of that's a start. Of course, there is more to security related to Google Workspace, and we give recommendations in how to optimize your security posture in Google Workspace. We configure a lot by default as secure as possible. But depending on what you want to do, security and usability or user friendliness is always need to be kept in balance, as you probably know. So that's something where kind of the most restrictive thing is maybe not the best idea, especially in the modern collaboration world. You might want to leave certain things open. You might want to enable people to share files via Drive, because then you still have them under control, which is way better if they would share the files through email attachments or upload them somewhere where you don't have access to it anymore, where you cannot apply anything anymore, where it's basically lost already. So it's about tailoring the things right. What we support is, and let me quickly open that. I had it open here already. We give you a checklist for each and every aspect of Google Workspace, where you can simply walk through and think about it. Okay, does it apply to me? Does it make sense for me? Like for Drive, do you want to limit sharing outside of your domain? So set it correctly. Set the default. Is it allowed to share files really publicly, or is it allowed only when users authenticate? Is it do you want to limit sharing only to a list of known addresses, a whitelisted domain, for instance, or do you want to open it up basically to everyone? So as for every single component in here, we have this checklist, which gives you a good idea of what might be good to look at. If it's really needed, that's a different story. That depends on the organization. That depends on the use case. But that's the core. And it really will never give you anything about like spin up a proxy server and filter traffic. That's kind of legacy approaches which don't work too well in a cloud native world, because they typically completely miss the point. Putting up this again. So I would definitely encourage you to walk through this checklist. And one more thing which might be relevant as well is to really understand how access and sharing can work together, not only from a permission perspective, but from a content perspective or from a context perspective. So first of all, your first choice would be, is the user who they say they are? If the user signs in, okay, this username is typically the email address. The password, okay, is the password. But that can be phished potentially. So what we definitely encourage to do is use multi-factor authentication. Multi-factor authentication is free of charge for any Google account. So absolutely no argument there against using it because it costs. No, it doesn't. It's always there. It's always there. It just needs to be enabled. And you as an admin can, of course, define, hey, I want to have that for my users enforced. So that's the first thing. Is the user signing in from a remote location, for instance? You can define based on the context-aware access. Okay, that's a trusted remote location. Circumstances look right. The device is okay. Context-aware access. So is the user really trusted to use to access Workspace, even if the user is fully authenticated correctly via multi-factor authentication? You might to decide that it's not okay to use all the services because of the circumstances. Of course, this happens quite often because this bring your own device concept is re-emerging, I would say, and it was pushed hard by the pandemic, obviously, because people were simply pushed to the home office from one day to the other, and maybe they did not have the devices there that were corporate managed, and so bring your own was kind of a reality from one day to the other, and I'm pretty confident it's here to stay. So that's something that you can meet with context-aware access as well, and you can still take control of the devices. You can still say, okay, that bring your own device is nice, but it's not encrypting anything, so we are not sharing any data to that device because it's not secure. So you can enforce that with the device management capabilities and the context-aware access. Then next thing, users authenticated, users accessing. Now the user is creating or modifying data. Is the user creating or modifying sensitive data? And what does sensitive mean? Sensitive can be personal identifiable information, can be social security number, credit card number, sensitive information that is specific to your organization, that only you know, a new project that is not allowed to be published, something like that. You know that stuff. You know the content. You know what to look for. And we support you to look for that and prevent that content from flowing out of your organization. And that's where data loss prevention comes in. So we simply restrict the sharing. So the user can access the data, but the user cannot print it, cannot download it, cannot make screenshots of it, because we enforce it not to happen. Or we can simply, we can have a balanced approach, like the user is allowed to do this, but the user receives a notification. Maybe they are not aware that it's sensitive and just want to go ahead and work and share it with others and realize, oh, oops, that's sensitive. So we can provide guidance. And data loss prevention is just built in and can help you protect your content, even if the user is fully authenticated and actually has all the rights to do so. So that's kind of the zero trust journey, as we call it. And there is, as you can see, no network and classic security aspect in here. It's all about access and access control. All right. And with that being said, I would say we will have another short break of another, maybe let's take it to 11:20. Quickly add this to my break slide. 11:20. A bit shorter than before, but then we have got 40 minutes left for the rest and for the Q&A. All right. So see you again in 7 minutes. So in 30 seconds, we're going to get started again. All right, here we go. Back from the break. We are now gonna enter the more or less last content chapter for today, so that we have some time left for questions you might have in the end. So what I'm gonna show you now is our approach to hybrid and multi-cloud security and analytics tools. I mentioned that before already. It's not that I can give you the full view of everything, so I just picked a few where I believe it's pretty clear how we address certain things, how we address the market, how we address customer requirements. There are many more capabilities out there, which I unfortunately cannot all mention today. But believe me, there is more than just the three that I'm going to mention today. So these three are addressing different aspects, different angles of use cases, and with that, different security aspects. The first part would be the application modernization approach that we have. I will explain what I mean by that. Then the data analytics and AI approach, all with the multi-cloud and hybrid aspect to it. And last but not least, the security analytics piece that we have. Each and every system follows this principle, which I mentioned pretty often today, this security built in, not bolt on. So let's dive into it. My first part would be the application modernization, and we have a solution called Anthos. Anthos is an evolution of many, many, many years of Google innovation and Google experience. So back in 2003, Google was a pretty young company at that time, but was growing heavily already. And we needed to have a solution which basically helped us orchestrate the resources, the IT resources that we had. And all the capabilities at that part were kind of not efficient enough. So we developed our own solution to automate the cluster management within our data centers. And that was called Borg. The Star Trek fans may recognize Borg is a species in the Star Trek universe, which tends to be centrally managing many individuals from a central place, and so we just took that name for our own infrastructure, managing the services, managing the clusters, and that management solution was called Borg. And through the course of the year, a lot of things happened related to containerization. In modern, I would say today, Docker containers or containerization is not something that is completely new. For some, it still is, but containerization is an important part of modern's IT strategy. dealing with a lot of limitations that classic virtualization brings, like virtualization of the whole operating system, again, containers, not virtualizing the whole operating system, just virtualizing the application, but making it kind of run like a service on top of the operating system. A lot more efficient than classic virtualizations, a lot faster. And these services tend to grow, and these containers tend to grow. You just look at the task manager of your operating system of choice, you see how many services are running at all times. And applications, full-blown applications in containers, just run aside of those services, but they tend to grow and they tend to scale. So one container is not enough to deal with the load, so a second container spun up, a third container spun up. That's how basically containerization works. But the more you get, the more you need to manage. And so we built a solution specifically tailored for those containers. And this solution ended up to be what you may know as Kubernetes, which was based on what we started back here, and then became open sourced, and is now, I would say, the de facto industry standard for container management. And that's a great achievement. We provide Kubernetes services within our Google Cloud Platform. It's simply called GKE. Google Kubernetes Engine, so you can run your containers on top of Google Cloud Platform, and we take care of the underlying infrastructure for you. The thing is, Kubernetes manages a lot, but is not built to manage across boundaries of clouds, of data centers. And so if you have your containers running in different clouds, you might want to have a management piece manage holistically overall. And this management solution is Anthos, built on different underlying technologies, which are also open source, like Istio and Knative. It's now the platform that gives you the ability to control containers across clouds on different layers, on different clouds, on different platforms, on platforms, no matter where they are. If they are on premise, in the cloud, it doesn't matter. You can directly attach any Kubernetes cluster that you have, but of course you can spin up your new ones using Anthos. Anthos is way more than just kind of this management piece, this single pane of glass. It's also about modernizing applications. So what we have within Anthos is technology to kind of transfer virtual machines into containerized applications. So bringing the best out of the virtualization technology into the containerized world. So that's kind of what Anthos is about. Of course, this single pane of glass and these capabilities that we provide in here, compliance and governance mechanisms that lets you define, for instance, a container may only be run of an underlying system which supports in-memory encryption. That's a pretty easy task if you have that in running in Google Cloud. But if you're running certain things on premise, and if you're running certain things in Azure and certain things in AWS and in other clouds, it's way more complex, because you need to learn anytime how the platform works and really make sure that it works at scale at all times. And so Anthos helps you with this end-to-end observability, enforcement of compliance and regulation. So you can really define, okay, if something changes in the infrastructure, in-memory encryption is not done anymore, I immediately stop the containers, for instance. That's something. And really, this bringing it up to the containerized layer can bring a lot of security gain as well. Because container deploy much easier, much faster. The containers integrate pretty well with any CI/CD strategy you might have. So patching a virtual machine with the operating system sitting underneath it is way more complex and is way more prone to errors and way more prone to kind of longer downtimes as compared to a container. So bringing this up to the container level can really help. It has everything, the formats, the management solution is basically open source. It's not a vendor lock-in. That's very, very important. So everything that you can see here can be used independently of Google Cloud. You see the code, you can use everything. What we do is taking out the complexity, making it scalable for you, take in our experience to make it as easy, as scalable, as secure as possible. But still, the technology that sits underneath it is open sourced, so you can use it basically independently of Google if you like. So that's Anthos. That's about the application modernization piece. Next part is, what about data? So application is the one side. You typically have data sitting somewhere and you probably want to do something with the data. You need to transfer the data from A to B. Every transfer from A to B might be a security risk on its own. If it's not kind of a move, it's a copy, then you basically need to control both areas. Complexity added. So we are bringing technology to more clouds, technology that we really believe in, which is the supporting technology, which for many Google services, and which is a supporting technology for a lot of modern use cases like AI and machine learning. And that is BigQuery. BigQuery, our data warehouse, analyzing the data at scale, very, very fast, very efficient. But now with this little term here, with Omni, able to consume data directly out from other cloud sources, like with their databases that they have on the other side. You still have the same single pane of glass in the Google Cloud world. You can do the same with BigQuery, no matter if the data is hosted within GCP, within AWS, within Azure. And you're not transferring the data. BigQuery Omni is effectively using queries on the other side, running it as efficiently as possible on the other side, just taking the data output, and just for the processing time, it's within Google Cloud. But the data is not fully transferred all over. It's really only for the processing. And you have basically the fresh data. You have a very simplified data movement because you don't move the data, you just access the data. That's a different part. And BigQuery Omni reflects the security settings, the authorizations, the roles of the targets. So something which is very complex, if built on your own, it's done for you. So taking BigQuery as the option for data analytics at scale, no matter where the data is, that is what BigQuery Omni is about. You see, it slightly shifted away from typical security discussions. It's not that I'm just saying, okay, we have the next security center and the next virus scanner and the next denial of service protection. We have that as well, but it's not kind of fixing certain issues, real world scenarios, because in the end, IT should serve a purpose. IT needs security, but security is not the purpose of IT. You need to do something with the data. You need to do something with the application. And so Anthos and BigQuery take a different route there, fixing the problem at the base, more or less, and not adding something superficially to it. Last but not least, that's our cloud-native security analytics solution called Chronicle. And maybe you followed it. We recently acquired a company called Simplify, which adds to the Chronicle functionality. What Chronicle is? Chronicle is, let's call it that way. It's Google search for security analytics. It's when you're using Google search, you're expecting results in milliseconds, basically good results in milliseconds. These results rely on data, large data, big data. And so it is with security-related data, log files in particular, as well. What Chronicle does, it takes all of the security telemetry that you add to it. It has lots of connectors, lots of options to add this. Identity-related information, firewall-based information, authentication information, EDR, XDR information, threat intelligence, vulnerability data, DNS information, which is very important for identifying modern threats, especially advanced persistent threats, network information. All is ingested, no matter where it comes from. It can come from Google Cloud, obviously, but it can come from your on-prem data center. It can come from other clouds. Just all the telemetry is put in there. And the idea is Chronicle takes a long track record of that data. So taking in data at a huge scale, petabyte-wise data, log file data, and making it searchable in milliseconds. Unfortunately, I cannot show you a demo today, but that's really how it works. It's very efficiently searching the data, and you can look into aspects that you can find out the information that basically is needed to identify advanced persistent threats, etc., which typically falls short in many organizations because they simply delete the log file data, or they are not using a single pane of glass for all the data that they have. They look at the one log file, they look at the other log files, but actually the combination of the log files, seeing what DNS requests the client does, and seeing what installations are done on the client, different aspects typically, often not looked at together. Chronicle does exactly that. Combines all the resources and gives you the ability to push in basically as much data as you like, petabyte-wise data at a fixed rate. It's not that you kind of, okay, the more data you put in, the more you pay. It's really about there is a fixed price depending on kind of your organization size, and it's always the same. So don't throw away the data that you might want to have at a later point, because if an advanced persistent threat started months back, it might cause the consequences right now. If you have thrown away the data from back then, you might be blind on that eye. So Chronicle fixes that issue and gives you the ability to search it at scale. And what we let me quickly, oh, sorry, that was what we recently acquired is another company called Simplify. And Simplify is a SOAR provider. So really action on the data. Chronicle by itself is really about analysis of the data, and obviously you can trigger the analysis and trigger other systems to do something for you. Like in that example that you say, okay, when this happens, then we notify the network team, blah, 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 something active. This tool set is provided by Simplify, and it's now integrated or will be integrated into Chronicle. So it really gives you reporting and action in one platform. But if you're already having something in place, like Splunk, like ServiceNow, like Jira, like Slack, wherever you might want to push that information to, you can still do it. So we integrate well. So it's not a limit here on the output side as well. On the input side, there is no limit because we consume everything that you give us. On the output side, you are free to choose what you do with the information. As said, with Simplify, we're gonna have an integrated tool set for providing more action, automatic action based on your definition. All right. That was a quick overview of the multi-cloud, hybrid cloud offerings that we have. There is more to it. There are solutions that some don't even recognize at Google as Google services, like VirusTotal. VirusTotal is our virus knowledge database. Basically, it's a Google service, and it's tightly built into Chronicle and into Google Workspace, for instance. That's something that you can basically use with every cloud because it's integratable with every application. We have a fraud detection service called reCAPTCHA. And reCAPTCHA protects your websites against malicious actors like bots trying to sign up, bots trying to enter information into a web form. This reCAPTCHA can help you solve that. And obviously, reCAPTCHA can sit in front no matter where the backend is. If that backend is hosted on premise, it's fine. It's integratable. So we provide a lot more than just the three. That's what I wanted to say. But yeah, multi-cloud in general is a very, very important part for Google. That's part of our strategy. That's part of how we address certain things. And we try to be as open as possible. You can see that also by how far we embrace open source technology within our platform. Many of the services that are kind of Google native in Google Cloud are actually based on open source or are Google built and then open sourced, like Kubernetes. Yeah, and with that being said, that was my kind of overview for today. We now have 20 minutes left for your questions, and I saw I mixed up the numbers. Actually, there should be a number 5, not a number 4 on that slide. Yeah, but I'm quite happy to take your questions right now. Feel free to chat or speak out. Meanwhile, maybe one of you is already typing. I'm just adding my mail address, and I saw Alina already. Thank you for adding your email address, colleague. I did not introduce you, sorry. Alina, my colleague in Norway, she also gave her email address and her telephone number. So feel free to reach out to us anytime you have questions, you are interested. We are quite happy to help. And if you want to reach out to me by email, it's pretty easy. Type it correctly, fopitz@google.com. That's my email address. And quite happy to set up a virtual conference, a phone call, or just have a quick email conversation. So no worries, just feel free to reach out anytime.
Thank you, Florian. There are no questions at this point. Oh, it was just Ragnar posting his email as well. So the question for me is then, should the attendees contact you or Ragnar regarding Google solutions?
I personally feel, hi Ragnar.
Hi.
I personally feel Ragnar is in Norway. He can speak Norwegian, which I can't. So if you feel like speaking Norwegian, please reach out to Ragnar, and we can align each other anytime. So no worries. Just decide on how you like.
And as Alina wrote, if you are a Norwegian kommune, then you have to contact her. Is that correct?
Yeah, she's with the municipalities, yes.
So Kjell Eines has questions for you.
Yeah. All right. So the question is, are there any resources for Google Workspace, best practice, etc.? So yes, there is. There is. And let me just spin that up again. So first of all, that's my main recommendation. It's public knowledge. So basically everything that we want to share, that we can share, is shared publicly anyway. So on our web pages, you see that checklists, which are pretty good to walk through and identify potential areas of action for you. The real area of action obviously always depends on what you want to achieve. My main recommendation is really about understanding how Workspace is built and really understand that this cloud native browser first approach, and just focusing your activities on the access control piece, because that's what you're that's what you can control, that's what you should control. That's something where we just provide the platform for you, where you should do it right. And here in this security checklist, there is a lot of things like how you should work with the accounts that are being set up there. What types of permissions you give them. Super admin permission, that's the first permission that you get when you spin it up. Obviously, like with the GCP side before, you don't want to have admin permissions on a day-to-day basis, because that's the opposite of least privilege. It's just too much. So the less privilege you have, the less attack surface an account potentially has. So really following that principle is very important. And like with the GCP side as well, we provide recommendations for you. And you see that here in this so-called security health area. If you click on that, it basically is another representation of the checklist shown before. You see, okay, that's our recommendation. That's where we say, okay, you might want to do something differently, and you have already dealt with it, and walk through it. These things are regularly updated whenever we see certain new patterns, new features that might require different settings, or if we see a shift of threats, in a sense, to our customers, then we add to this. And regularly looking at this keeps you at a very, very good state. But honestly, it's not about just kind of shutting down everything and just restricting everything to the minimum, because that might cause collateral damage in that sense. Users who are not kind of using the system as they like it to use will look for different systems. And then you have another form of shadow IT happening somewhere else. They are sharing the files independently. So it's always a challenge to find the right balance. Where that balance is unfortunately an organizational decision. It's not that the same applies to everyone, but to answer your question, in summary, 2 ways: the security health, best practices, and the checklist. These would be my main 2 recommendations to look into. All right. Any other questions? Would you say Google as infrastructure is more or less under attack in terms of which platforms are targeted compared to other vendors? To be honest, I feel like it's hard to compare it in a sense. It's certainly that we see a lot of attacks happening against our platform. Is it just kind of by the numbers? Is that shared so publicly in a sense that we just could say, okay, Azure had that, we had that. That's a hard the hard thing. But the honest answer to it is, the more users, the more data you have and manage, the more likely you become of being the next target. And as said, we are covering a lot of users. We are covering a lot of data at scale with the core systems that we run with up to 3 billion users. Like Gmail is hit hard by different attackers, is hit hard by phishing waves, etc. And we are constantly learning from it. So I feel the typical Gmail users experiences less spam compared to other vendors, at least from my perspective. Is this a very kind of objective result where I could just give you the numbers? It's like that? Honestly, no. But the feedback that we get from the customers is very, very positive on that side. So I saw like the attacks are growing on all ends. Only recently, I guess, Microsoft made an announcement where they countered a huge denial of service attack in, I guess it was in Singapore or something. I guess it was in the Asian area, and they tackled it that way. A year ago, Google had an attack with approximate the same altitude. So pretty heavy, but it's growing all the time. So I guess the next hit that's gonna come will be even larger. So it's always about keeping up, and we do a lot in terms of identifying the threats pretty early. So our Project Zero team, for instance, is very popular in the industry for identifying lots of threats early. And to be honest, when we identify the threat, it's the first thing that we do is tackle the threat on our systems, because we are typically not allowed to publish more knowledge on it, because we want to give the others time to react to it. And provide patches and so on. But the first thing we do when we identify a threat, and our project zero team is very, very important part. The first thing we do is we protect our infrastructure, and then we share the knowledge publicly as soon as we are allowed to do so. Anyone we can contact if we are private sector, not community. I mean, the support is pretty great already for enterprise. Honestly, yeah, you even if the three of us today are kind of more focused on the public sector area, that does not limit your capability to just reach out to us, and we will find the right contact for you. So please feel free, just reach out to us and we will find the right one for you. All right. Any other questions?
It seems that there are no more questions.
Mm-hmm.
And we're quite there on time as well. So
very good.
That means that this is the end of the Google Security Day with Florian Opitz. And the Hackon team would, of course, like to thank you, Florian, for guiding us through this event. And thank you for watching this session.
Yeah. Thank you for the opportunity. Have a great day, all. And as said, please don't hesitate to reach out if you have any questions, concerns, anything to discuss. Thank you.